A person holds a 3-meter long 20-kilogram uniform bar horizontally with two hands. One hand at the left end of the bar and the other hand 60 centimeters away. Find the magnitude and direction of the forces F1 and F2 the person exerts on the bar. In this problem, we have two unknowns, F1 and F2 to find. So we need two equations. We need both the net torque equals to 0 and the net force equals to 0. Now let's draw the force diagram. The bar has a mass, so there is a mg acting on the bar, and the bar is uniform, so the mg acts at the center of mass, which is right in the middle of the bar. So this is the mg. The bar is 20 kilograms, so the mg is 200 newtons. The bar is also touching the two hands, so there are two forces F1 and F2 acting on the bar. In which directions do you think these two forces would go? Many students would make them both the upward forces when they see this problem for the first time. But are they both upward? One way to help us figure out the direction of a force is to think what would happen if we would take away that particular force. In this case, if I take away F1, this point of the rod would go up. This means that F1 must be a downward force, so it can keep this rod in place. If I want to know which way F2 goes, I just have to keep F1 in place and take away only F2. When I remove F2, this point goes down. That means F2 must be an upward force, so it can keep the rod in place. You can also do the same thing with a pencil. For F1, if you remove F1, this end of the pencil goes up, so F1 must be a downward force. And then keep F1 there and remove F2. This time, this point goes down, so F2 must be upward. So F1 is a downward force. F2 is a upward force. Now let's write the torque equation. The net torque equals to 0. That means the clockwise torque equals to the counterclockwise torque. To write the torque equation, we need an axle. Again, there is no natural axle over here, but we can use a pretend axle. The best place for a pretend axle is a place where you have the most unknown force. Usually that's the case. So we have two unknown forces, F1 and F2, so either of these can be a good choice. I'm just going to use the F1 as my fulcrum. So this is my fulcrum over there. That means the force F1 will have the 0 lever arm because it acts right on the fulcrum. So no lever arm, no torque. That means F1 is not going to show up in our torque equation. mg is going to give us the clockwise torque. F2 will give us the counterclockwise torque. The clockwise torque is produced by the 200 newtons times the lever arm, the distance between the line of force and the axis. Since this is a uniform bar, the mg is right in the middle, and the bar is 3 meters long. That means this distance here is 1.5 meters, half of 3 meters. The counterclockwise torque is produced by F2. And what is the lever arm for F2? It is 60 centimeters. But we need it to be in meters, so I have to change 60 centimeters to 0.6 meters. Now this will give us F2, that is 500 newtons. Then we can look at the net force is 0. Net force being 0 means the upward force must equal to the downward forces. The upward force is F2, which is 500 newtons we just found, and the downward force is F1 plus the mg, 200 newtons. And this one gives us F1, that is 300 newtons. and F2 is an upward force, F1 is a downward force. In case if you get the direction of a force wrong, you can still solve the problem the same way. You will just find that force to be negative, and this should tell you that the force must be in a wrong direction. For example, if you think F1 is an upward force, then you would have a force diagram that's like this: F1, F2, and mg, 200 newtons. And then let's say I still choose the same location as the fulcrum. So when I write the torque equation, everything will be the same. mg will still be the one to provide the clockwise torque. The F2 will still be the one to provide counterclockwise torque. So we will still find the F2 to be 500 newtons. But when we write the net force equals to 0, the upward forces will be F1 plus F2, and that should equal to the downward force, 200 newtons. So you will have F1 plus 500 equals to 200, and then you will find F1 to be negative 300 newtons, which means it is really 300 newtons downward force. Other problems similar to this one include a diving board problem like this. You have a diving board that is held in place by these two supports. You may have the person's weight and the diving board's weight acting on the board. And you can be asked to find the two forces from the two supports. Just like the problem above, this support here will provide a downward force, while that support provides an upward force.